Hi everybody. For Module 4, we're going to talk a lot about right triangles. And what we want to talk about for 4.4 is some special right triangles. So we're going to talk about two types of right triangles that have some special properties. That's why we call them the special right triangles. Now we name them based on their angle measures. So there's two common names I'm going to say. I'm going to talk about a 45-45-90 triangle and a 30-60-90 triangle. And for both triangles, I'm talking about their angles. So notice, first of all, each one of them has a 90 in it. That's what makes them a right angle. The 90-degree angle is a right angle. So the other two angles in one of them, we're saying both angles are the same. They're both 45. And in the other one, we have a 30 and a 60. So those are our two special right triangles. Let's talk about what's special about them. So we'll go one at a time. Let's start with the 45-45-90. Now, another name for a 45-45-90 right triangle is an isosceles right triangle, and that's because the two legs are congruent. Now, the reason the two legs are congruent is because the two angles are congruent. So remember, a little while ago, it's been a little while, but we learned that in a triangle, opposites match up, like opposite, the smallest angle is opposite the smallest side, biggest opposite biggest. Well, we also learned that whenever two angles are equal, like the 45s here, then their opposite sides have to be the same too. That's why those two sides are congruent. So when I say a 45-45-90 triangle, I'm saying two sides and two angles are both the same. And that's why we sometimes call it an isosceles right triangle. Now here's what's special about it. Once you notice it's the 45-45-90 triangle, we have a really easy trick for taking one measure and using it to find the other. So if you know the length of the legs, it's the same. Remember, the legs are the same. So if you know the length of those two legs, all you have to do is multiply it by the square root of 2, and it'll tell you how the hypotenuse is, how long the hypotenuse is. And then that works backwards also. If you know the hypotenuse, you can take that and divide it by the square root of 2, and it'll tell you how long each leg is. So that sets us up for a really easy problem. So for our first example, I'm going to do three versions of it with you. I'm going to say, let's find the missing side lengths of each triangle below. So I look at the first picture, going kind of left to right there, the one with the 45 degrees and the 8. And I say, I see that red box on top, which means a right angle. I see one angle marked 45. Now, even though it's not marked, that tells me that this other angle is 45. It has to be, because the three angles have to add up to 180. So that's a 45-45-90. What that means is the two legs are the same. So without doing any work at all, I can say the other leg is 8 there, because these two sides here are congruent. They're both 8. So the only thing I really need to do is figure out how long the hypotenuse, which is the bottom of that triangle, is. Now, we could do Pythagorean theorem. A squared plus b squared equals c squared, do some work and find it. But this is a shortcut. We say, wait a minute, we have a shortcut for 45-45-90. If I know that the leg is 8, all I have to do is multiply it by the square root of 2, and I get my answer. And I don't even need to simplify it or use a calculator. I'm just going to say the answer is 8 radical 2, or 8 times the square root of 2. If you need to know how long that is, type it into a calculator, get a decimal. But for now, we're just going to leave the radicals in there. Okay, now picture number 2 looks very, very similar, but no angles are marked. So what I'm doing with these first two pictures is I'm talking about how you would know it's a 45-45-90 triangle. In the first picture, one of the angles was marked 45, so we knew they both were. In this picture, no angles are marked, but what you see is that the two legs are the same. This is 3 radical 2, this is 3 radical 2. If those are the same, then these angles are the same. And in a right triangle, if the angles are the same, they have to both be 45, again, because it's all got to add up to 180. So because those are both 3 radical 2, I know this is a 45-45-90 triangle. And I can say, well, all I have to do is multiply by square root of 2, and I'll get my hypotenuse. Now here's what happens when you do that. I'm going to do a little bit of work off to the side here. I'm going to take my 3 radical 2 and I'm going to multiply it by another radical 2. Now leave the 3. Let's just look at this part right here. If you take a square root and you multiply it by itself, what happens is the square root gets canceled, because multiplying something by itself means squaring. Square root of 2 times square root of 2, another way to say that would be the square root of 2 squared. And in that case, the square root and the squared cancel and it just turns into a regular 2. So I have 3 times 2, which is 6. So my final answer here, that missing side, is 6. So when you get that, if you have something that already has a radical on it, and you're multiplying it by a radical, another way to think about that, let me show you another way here. Another way to think about this question, the square root of 2 times the square root of 2, when you're multiplying radicals, you can just multiply the numbers. And 2 times 2 is 4. And then the square root of 4 is 2. 4 is a perfect square. So we get 3 times 2, which is also 6. So however you think about it, it does come out to just the number 6. The square root of 2 times the square root of 2 is just the number 2. And then we multiply that by the 3 that was there the whole time. Okay, last example. So same as the middle example here. I don't know what the legs are, but I know they're the same because they're both marked X. And if they're both marked X, they're both equal. And if those are equal, then these are equal, and that's what makes it a 45, 45, 90 triangle. So this is a 45, 45, 90 again for the 3rd time in a row, but this time I didn't tell you how long the legs are, I told you how long the hypotenuse is. So I told you on the slide, on the last slide. This works backwards too. If you know how long a leg is, you multiply by radical 2 to get the hypotenuse. If you know the hypotenuse, you can divide by radical 2 to get the leg. So if I take that 5 square root of 2 and I divide it by the square root of 2, then what happens is those square root of 2's cancel and you just get a 5. And that's our answer here. These legs, which are both the same, are both 5. So there's our first shortcut for special right triangles. If you have the 45, 45, 90, you can either, if you know the leg, you can multiply by radical 2 to get the hypotenuse, or if you know the hypotenuse, you can divide by radical 2 to get the leg. So let's talk about our other special right triangle, the 30, 60, 90. Now again, we're talking about the angles. We're talking about a triangle that has a 30 degree, a 60 degree, and then the right angle, which is 90. And what's different is the legs are not the same on this one. So here's a picture of a 30, 60, 90 triangle. It's not an isosceles right triangle. In the last picture, our 2 legs were the same. In this one, as I mentioned, you can see one of them's shorter and one of them's longer. So in this picture, that's going to be called the short leg over there on the left. The bottom, the way I've drawn it here, would be the longer leg. And then the diagonal side, that's actually the hypotenuse. That's not a leg at all. So just remember, by definition, the hypotenuse is opposite the right angle. We've used hypotenuse a lot. That's not a big deal. Use that same property we just talked about. Angles and sides match up. Since the 30 degree is the smaller angle, it's going to be opposite the shorter leg. And since the 60 degree is the bigger angle, it's going to be opposite the longer leg. So you have 3 different parts. It makes it a little bit harder than the 45, 45, 90. Because you have 3 different parts, we got to know the relationship between all of them. So here's our shortcut relationship for the 30, 60, 90. Number 1, the hypotenuse is always double the short leg. Twice the short leg times 2, however you want to think about it. So if I know the shorter leg, I can multiply it by 2, I get the hypotenuse. The longer leg is the shorter leg times the square root of 3. So not the square root of 2. Square root of 2 is for 45, 45, 90. Square root of 3 is for the 30, 60, 90. So each one of these works backwards by dividing, just like 45, 45, 90. And a good way to think of it is they're all related, but it's easiest if you can find that short leg first. Short leg times 2 gives you the hypotenuse. Short leg times radical 3 gives you the longer leg. Now, to get from the longer leg to the hypotenuse, it's easier to use the shorter leg. Don't try to go straight from one to the other. So let's look at a couple examples of this. So we'll find both x and y in this picture here. So first of all, it is a 30, 60, 90 triangle. I wrote that very clearly this time. I labeled all the angles. You got a right angle down there with the red box. You got a 30 and a 60. And then I look at the 9. The 9 is the number I gave you. So let's figure out what that one is first. Let's figure out like what the name of it is. Is it the hypotenuse, the long leg, or the short leg? So I look at the picture. I notice that it's opposite from the 60. So what it is the longer leg. And that means the 30, opposite it, x becomes the shorter leg. And the y is opposite the right angle, so it becomes the hypotenuse. So the one that I know in this picture is the longer leg. Now remember, everything goes through the shorter leg. That's kind of like our main one that we want to focus on. So the first thing I want to do is find out what that shorter leg is. Now the relationship between the shorter leg and the longer leg was the square root of 3. If you know the shorter leg, you can multiply by square root of 3 to get the longer leg, or in this case, if you know the longer leg, you can divide. So that's what I'm going to do. To find the shorter leg, which is x, I'm going to take the longer leg, which is 9, and I'm going to divide it by the square root of 3. Now, depending on the question, you might want to just leave that. We might also want to give a decimal answer. For now, I think I'll just leave it. Let's just say our answer right here is, for shorter leg, is 9 over radical 3. But what we want to do next is find the hypotenuse. And the hypotenuse, the reason I said find the shorter leg first, you can't really go straight from longer leg to hypotenuse. We don't have a rule for that. But once you know the shorter leg, the rule was the hypotenuse is always twice that, times 2. So to find the hypotenuse, which is y, I'm going to take the shorter leg, which is 9 over radical 3, and I'm going to multiply it by 2. Now when you multiply a fraction by a whole number, you're basically just multiplying it times the top. 9 times 2 is 18. So what I get for this one is 18 over radical 3. And that's going to be my hypotenuse. That's the answer over here. So x is 9 over radical 3. Y is 18 over radical 3. If you want to type it into a calculator and get a decimal, that's fine. You can. You don't really have to. We'll do it later. We'll do another problem where we'll do that. But for now, I just want you to get the idea of, when do I multiply by 2? When do I divide by 2? When do I multiply by radical 3? When do I divide by radical 3? All right, I'm going to erase my work because I have a second example for us here. Get rid of all that. So let's look at this question and let's realize why this is a 30, 60, 90 triangle first. So when I look at this question, if I start looking at, don't look at the red line down the middle, look at the big triangle, the whole thing. What I have, if I look at my sides, I have a 4 here, I have a 4 here, and if I add this up, 2 plus 2 is 4 here. So what I have is an equilateral triangle. Now an equilateral triangle, the sides are equal, the angles are equal. There's 3 angles in a triangle. 180 divided by 3 is 60. So each one of these angles becomes 60 degrees. And this one up here is 60 degrees, but the red line splits it in half. And 60 divided by 2 is 30. So that's why if you look at that picture, either one of the 2 triangles, the right one or the left one, doesn't matter which one, they're both 30, 60, 90 triangles. So if I redraw just one of those triangles, let's say I do the one on the left there. I have the right angle here, I have a 2 here, a 4 here, this is the 60, this is the 30. There's my 30, 60, 90 with a 2 and a 4. Now it says find each missing length. We're trying to find h right here. Now, in my picture, the 4 is the hypotenuse. Opposite from the 30, this is the shorter leg. That means what I'm trying to find is the longer leg. Now, the two that are already given, the hypotenuse and the shorter leg, make sense because the hypotenuse is supposed to be 2 times the shorter leg, and it is. 2 times 2 is 4. So my rule to answer this question, you want to take the shorter leg and multiply it by the square root of 3, and you'll find the longer leg. So if I take the shorter leg, 2, multiply it by square root of 3, that's my answer for H there. So the second triangle, the key was realizing, first of all, that it even is a 30, 60, 90 triangle. Once you realize that, the work was actually easier than the first one. The first one we had to find 2 different things, and we had to divide by radical 3 and this and that. This one was just realizing what you're looking at, taking the 2 and multiplying by root 3. So here's our last example, and this one I am going to go all the way to a decimal on because I want you guys to see this is a word problem, so we would probably want like a real answer. So what I said for this question, I said a baseball diamond, what we call a baseball diamond, like a field you play baseball on, is actually not a diamond, it's a square. It's just drawn diagonally, so we call it a diamond. So like, let's say this is my baseball diamond right here. And this is H for home plate, this is first base, this is second base, this is third base. So here's our bases. Here's our home plate right here. And I said the distance from home plate to first base is 90 feet. So here's 90 feet. Now remember, I also told you it's a square. So these are all 90 feet. Then I ask you guys, what is the distance from home plate to second base? That would be a straight line from here to here. Now what I've done, we had 90-degree angles everywhere because this is a square. That line down the middle cut them exactly in half. Well, half of 90 is 45. So you have a 45, 45, 90 triangle right here on either side. Or because these are both 90, see these are the legs now of my right triangle because they're both 90, that makes it a 45, 45, 90. So all I'm asking you guys to do is apply what we just learned. Once you draw the picture and realize you're looking at a 45, 45, 90, you say, okay, if I kind of cut this baseball diamond in half and I look at half of it, the legs are 90, the yellow line that I drew down the middle, which is the answer to the question, is the hypotenuse. So the answer is 90, which is our leg, times the square root of 2. Now here's an example where I would actually want the answer in feet. You know, this is a word problem. If I ask you guys, how far is it from home to second base, and you told me 90 square root of 2, it's not that meaningful. So this is where you grab it into a calculator, you type it in. I actually already did it. It comes out to about 127.3 feet. So on a baseball field, the distance, like if the catcher is throwing to second base to try and catch somebody who's stealing or something, the distance is 127.3 feet for that throw. And that's just an example of an application, a real life example of using a 45, 45, 90 triangle to figure out a distance.